Hello everyone, welcome back to my channel. I hope you are doing extremely well. So today I'm again came back with another important problem of dynamics reach. Let's read and understand the problem carefully. Grid unique path. So we have given two integers m and n representing the number of rows and columns of a 2D named matrix. Return the maximum, then have to return the number of unique ways to go from the top left cell to the bottom right cell, right? And the movement that can be done from any cell is allowed only in two directions from that cell, either right or bottom. So let's see with the example. So there's given in the example that m is 3 and n is 2, right? So m is the nothing but the number of rows and n is column. So we are at the top left cell, okay, and we have to reach at this cell, at the bottom cell, right? So the how many ways or unique path to reach from the top left cell to the bottom right cell, right? So the first path would be what? Let's see, and the movement only allow either in right direction or bottom direction, right? The first path would be this, then they cannot goes to the right, they come down, then down. This is the one path. Then another path will be from here I will go down, then I will go right, then again I will go down. The another path would be I will go down, then down, and like right, and that will be goes from here because here I have in the right, so from here I will choose the down, then I will goes to the right. So there are three unique paths. So the answer is 3 here. Okay, I am sure that this example clear. Let's see with another example. So here given that there is a grid of m equal to 3 and n equal to 4. Okay, m indicates the number of rows and n indicates the number of column. So I am here at this, let's suppose that I am here, I have to reach here, right? I have to go from top left cell to the bottom right cell, right? How can I go to that cell? So there would be a two choice, right? And go here. So from here I have two options. Either I will go to this cell or I will go to this cell, right? The bottom. Let's suppose that I have gone this, then gone right, okay, then gone right, then gone right. Then from here I cannot go to the right, then I moves down and I reach there. This is the one path. Then the another path would be what? I will go backtrack, and backtrack from here I have taken the right. So can I take the down? Yes, I can take down. Then again I will take the right and I will go. This is another path. The second path would be what? From here I can go to the down and I will reach there. This is another path. Again I will do backtrack and I came here. From here I have taken the right path. Can I take the down path? Yes, I can. From here I have taken the down path, then I have gone there, right? And from here I have two options as well. Either I can go to this cell, then this, okay, this is there also another unique path, or I will go to this and this is there also another unique path, right? From here also I have two options. Either I will go to the down, because I have already taken the right path, I will go to the down. Okay, so let's see if I will calculate here. So this is the one path, plus like this is the another path, plus this is the another path, plus this. From here there are two options. From here there are two options, right? From here we have three options, right? From here we have four options, if I'm not wrong. From here there is three options, okay, and because there this I can go this down, this down, this down, and one path, two path, three path, four path, plus 4, and from here I will take this right, then goes down, or I will take this one, right? 1, then 2, then 3, 4. This will be 5. So the total how many paths is there? 5 plus 4 is 9. 9 plus 3 definitely is 12. 12 plus 13 is 15. There is a 15 number of unique paths from this two shell, from this matrix. So how can we do it? If you see carefully, at any cell I have two options. Either I can, at any cell I have two options. Either I can go from right direction or bottom direction. We started from this cell, right? So we are at the 2, 1 cell. Okay, let's, as we know that we have calculated from the top down, so I will go to that one. So now we are at 0, 0 cell, right? We are at the top left cell. So we have two options here from here. either I will move to the down, that means 1 0, or either I can go to 0 1, right? This is the basically right, and this is basically down. From here as well I have two options as well. From down I have two options as well. I can move to the down 0, or I can take the 1 1. Yeah, from here to I can goes down, right? From 2 I can goes down, that's 3 0, but 3 0 is we reach the boundary of the matrix, so it gives me there is no any unique path, so it gives me 0 return, right? But see, here carefully, but see here that 3 0, right? And what is happening here, 2 0, so I cannot goes down, right? I will goes to the right direction. Now from 2 I can goes 1, and this is the expectation because we have reached our goal. So from here if we reach our goal, so I will simply return 1 from here. Got it? So from 2 0 if we are at here, this means that from 2 0 cell there is one path. Got it? It's clear. Now I will move to the up. Now from here we know that if I will from 1 0, if I will 1 0, this is 1 0, if I will goes to the down, then there's one path. But if I will take the right, means here, then from here I have two options, right? Either I can goes to the down, that is nothing but 2 1, or I can goes 1 2, means right. If I again reach the 2 1, this is the expected our cell, means destination. So from here it gives me 1, but see here 1 2, this 2 is the out of bound, it reached the boundary of the column. So from here it gives me the 0 as expected, right? So 0 plus 1 is 1, so it gives me again 1. So from here 1 and 1. Yeah, so we need to reach 2.1 distance. We are at here. So if here indicate 1 0, so this is 1 0, simple 1 0, it indicates that there is two options. If I will take right, then it gives me 1 unique path. If I will go down, then it gives me 1 unique path. So from 1 0 total unique path is 2. Simply I will return from here, right? 2. Yeah, from here if I will take the down, then it gives me 2. If I will take the right, if I will take the right, then what it gives from again I have two options. Either I can move to the down, that is 1 1, or I can move to the right. This is also I reach the like a boundary, so it gives me 1, it gives me 0 because it's invalid choice, right? So from 1 1, I have two options. I can either move, I can move to the down, or I can move to the right direction. So if I move to the down, then I can reach 1 2, right? But if I like 2 1, right, down. If I will goes to the right, then it gives me 1 2. This is in the invalid choice, so it gives me 0. So 2 1 is expected, so it gives me 1. So 1 plus 0 is 1 definitely, and 1 plus 0 is 1. So if from 0 0 if I will take the right, then it gives me the 1. So the total path is 2 plus 1, that is 3, and this is our answer. So let's try to write down the pseudocode for this recursive approach. So basically, yeah, let's basically take this reference. This is basically read, okay, and this is the am or an, right? And this is the current row where I am and current column, right? The first base case is that I will check. Base case, I will check that if I reach the boundary, right, means that current row equal to am, or current column equal to n. So it means that this is the like invalid or a boundary that I have reached. So simply return 0, right? But if it is not a boundary, like boundary reach, now the base case 2 is that that if a row equal to m minus 1 and column equal to n minus 1. So it means that I have reached the expected cell or right bottom cell. So simply from here return 1, right? Now let's try to write down that move, simply move right. So and at the below move downwards. So basically if not if integer right, that is nothing but call function and pass grid. Okay, wait, actually I don't have to pass any grid because we are doing based upon the rows and column, right? So you don't have to pass grid. Just call function, then pass m and we are moving right direction, so row will be as it is, and the column will be column plus 1, right? And in the down direction into like a down move, that is function m and then row plus 1 column. Simply from here I will simply return so simply from here I will simply return like a right direction count plus down move count. That's it. So I am sure that this recursion like a pseudocode helps you to understand, and this is language independent. Okay, so let's come to the code editor and try to write down this code clearly. If like a m equal to current row, or simply like the current column will reach to the like a last index or like a boundary, then simply from here we simply return 0. So this method will check the boundary, check if we reached the boundary, right? Check if like reached the right down cell. If m equal to current row m minus 1 and current column equal to n minus 1. So in that case this is the current path. So I will simply return 1. That's it. And from here like move right action into right action count, find unique path m and current row plus 1 column. Okay, wait. And as I am moving the right direction, so the row will be as it is, right? Move the down direction, down count. Yeah, it's worked perfectly fine. If I will try to submit the code, then might possibly gives me the time limit exceed error. Let me check. Might possibly gives. So let me, yeah, comes. Yeah, definitely gives time limit exceed. So why? Because at every cell wherever I am, I have two options. Either I can move right or I can move down, right? So as every cell we have like two options and there are n number of cells. So the time complexity would be 2 per power n, right? And what about the space complexity? That is order of n. So can we optimize this time complexity? Yes, as well, with the help of memoization. Let me tell you why memoization. If I will comes to the recursion tree again, then we can see over there are so many cells that we are calculating again and again. See, 1 1 we are calculating here, again 1 1 we are calculating here, right? See here, there is a 2 0 here, over that there is 1 2 over, we have calculated once, then 1 2 here, right? Then 2 1 here, then 2 1 here. So it means there are so many cells which we are visiting again and again. So we can avoid to revisit that same cell again. Instead of, we can save that answer in somewhere and we can use whenever we require that cell, right? So let's try to analyze the thing. So yes, definitely can use DP, right? Yeah, so what we will do basically, store that current cell value into memory or into DP, and definitely we can do it. So let's come to the code editor and try to write down the code directly. Okay, so here what I will do, I will simply create one 2D DP. Is an M and N, and we simply write down, we pass the DP, and we simply use that one, and from here also we can reuse and call to that. And we check if a current cell has already or not. DP not equal to 0, then I will simply return whatever the DP current value is, that current row column. At the end I will simply initialize current row column, right? Let me check here. If I call this thing, check, yeah, it was perfectly fine. I start to submit the code, and let me check. Yeah, it's submitted. So yeah, this is all about DP. If I now talk about the time complexity after applying DP, so that is nothing but order of n. Why? Because every cell we are calculating once, means we are visiting once. And if I talk about the space complexity, so order of 18, definitely here, not n, because n across m will be the space complexity. Why? Sorry, yeah, because we are using recursion. Okay, so at most there will be, and whatever space complexity here we are using DP, so n cross m would be the space complexity for this approach, right? So this is all about today video. Thank you so much for watching the complete video. I hope this video helped you a lot.